Welcome back. This is College Algebra, Property of Exponents. This will be our second video. Last time we talked about regular exponents, integer exponents. In this video, we will learn about rational exponents and how they are similar and different to the exponent rules that we saw earlier. So let's go back to our properties of exponents. So every single property on this list holds for any rational number. And so right here I'm going to underline rational numbers. Rational is just another word for fractions, and it turns out that sure enough, all the rules that we know for exponents still work for when their exponents are fractions. So let's try some problems. First, let's go ahead and do this one. We're going to use the properties of exponents to simplify. This time we're going to assume the variables are non-negative real integers. This is because of square roots, but we'll get into that a little bit later. All our answers should be without negative exponents. So no negative exponents allowed. So if you recall, when we want to simplify this, we need to add the exponents. That's the rule. In fact, that's what we should have learned in the last video, is that an easier way is to add the exponents. So for this problem, the way to start is that we want to say this is equal to x to the power 3/4 plus 1/5 plus 1/2. And by now, most of you, all of you I should say, are very good at adding fractions and finding common denominators. And in fact, this is what we have to do here. We look at these three fractions and we want to find the common denominator. So we look at the denominators here, these denominators, and we want the common denominator. And we know that the common denominator is 20. All those numbers go into 20. And so what we do is what we always do. We find the common denominator. And so right below, the way I'll write this, I'll say x is equal to something over 20 plus something over 20 plus something over 20. And you guys know that, for example, here, to go from 4 to 20, we multiply by 5. So 4 times 5. So I'm going to write it here in red, times 5. So 3 times 5 is 15. And then the 5 times 4 is equal to 20. So 1 times 4 is equal to 4. And the 2 times 10 is equal to 20. So the 1 times 10 is equal to 10. And we know that with fractions, once we have the common denominator, we can go ahead and write the numerators. 15 plus 4 is 19. 19 plus 10 is 29. 29 over 20. And we're going to leave our answer in this form. So this is the answer for this problem. Later on, we're going to translate this. This having the exponents as fractions actually means something. And so later on, we will rewrite this in a different way. Okay, let's try another example. By the way, when you see these examples, feel free to pause it and try it on your own and see if you get the right answer. Okay, here. So we have a couple of rules. First, or actually one rule. First of all, if you remember, when you have the same base and they're one over the other one, then what we do is we take the exponents and we subtract them. So in this case, what I would do is I would say, okay, so it'll be x to the 1/6 minus 1/3 times y to the 1/2 minus 1/4. Notice you always take the top exponent and subtract the bottom exponent. Always. This will always be true. And so then again, you need a common denominator. So for the x, for these two, for the 6 and the 3, for the 6 and the 3, for the 6 and this 3 over here, the common denominator would be 6. So I'm going to go ahead and write this x over 6 minus 6. And here, the 6 times 1 gives you 6, so 1 times 1 would be 1/6. And here, 3 times 2 would give you 6, so 1 times 2 is 2. And then for the y, the common denominator of these two exponents, this guy and this guy, is 4. So I'll go ahead and write 4. And now we multiply the 2 times the 2 and the 1 times the 2, so that gives us 2/4. I don't really have to change that one. And now we just go ahead and do the math. So here we get x to the 1 minus 2, which is negative 1/6, times y, 2 plus, oh, I wrote a, sorry, this is supposed to be a minus right here. Sorry, that's a mistake. 2 minus 1 is 1, so it's to the 1/4. And then let me scroll a little bit here. And then we want exponents as positive, so this negative exponent means reciprocal, so the x to the 1/6 goes here, the y to the 1/4 is here, and this would be the correct answer. Y to the 1/4 divided by x to the 1/6. Okay, one more. Again, we're using exponents. And so now we have this negative, and so recall that the negative just means to find the reciprocal. So here, I would start off by saying, oh, let me take the reciprocal, 3y to the 1/2 over 2x to the 3/4 times 2. And so now this means, if you recall, what this means is that we have this 2 times. But the easier way, the quicker way to do this is that we need to square everything that's inside of the parentheses. Everything must be squared. And so in order to do this, the way I would write this is as follows. I would say, okay, well, I gotta square the 3, so 3 squared. I gotta square the y to the 1/2, so we'll square that. I gotta square the 2, so we square that. And I gotta square the x to the 3/4, and so we square this. And so when we work this out, 3 squared is 9. Here I multiply the powers, 2 times 1/2. So you know that 2 times 1/2 is 1, so this is y to the first power. 2 squared is 4. And here, multiply the 3/4 times 2. And so those of you that don't know, can't multiply this quickly, 3/4 times 2 is just 3/4 times 2 over 1. You can simplify this as follows. 2 goes into both of these, 1 time here and twice here. 3 times 1 is 3, and 2 times 1 is 2, so I get 3/2. So I get x to the 3/2. Or, the way we usually write this is 9y divided by 4 x to the 3/2, and that would be our answer here. So this is how we deal with exponents. The rules work out exactly the same. In the next video, I will actually give you a different way of looking at these exponents. I'm going to stop here because this is 7 minutes, but I do want to continue this second part where we will actually look at the following. So let me give you a little preview. We will actually look at this way of looking at rational exponents, this general form, and so hopefully this will help. Okay. I'll see you in a bit. I'll talk to you in a bit.